Hello, everyone, and welcome to day two of the 2025 International Mission to Mars Design Engineering Competition. Today, we will have critiques from one team to another. So, Riot Academy, Team One, you have the floor.
Okay, thank you so much. Okay, so I'd like to begin with critique about Team Solace. The chosen location won, so I'll just be listing out the points that we have. Um, and yeah, so the first point is that the chosen location includes surface tilt and obstacles that would impair rover movement. There's no assessment of navigability or terrain risk that's provided on the slides. This might have not been clear, but they probably have it in the research paper. The provided coordinates are approximate and lack precision. On Mars, this margin of error can span tens, hundreds of kilometers. So I just wanted to make sure where like precisely where the site is being held. The power output from the fission surface power system, or FSP, is listed as 40 kilowatts without specifying the time interval. Whether this is per hour or per day is not clarified. Fourth, the hydroponics presentation omits growth time for spirulina and nutritional yeast. Plant yield is not quantified. The unit of energy is incorrectly listed as grams, which is not a unit for calories. Caloric values are presented without context. There's no indication if values are per kilogram, per 100 grams, or otherwise. Then there's no data provided on light sources or nutrient formulations for hydroponics. There's no identified source for nutrients, and no information is given about waste treatment or recycling loops. The proposed astronaut guide is undefined. There's no nutrient breakdown, no macronutrient ratios, and caloric needs are presented as a single average value. And the Martian paper airplane challenge lacks instrumentation. A paper airplane without onboard sensors cannot really provide the aerodynamic data that we need, such as lift, drag, or stall behavior. And there is really no flow visualization or stereoscopic tracking method, which is mentioned. I understand that this team wants to collect data in low density atmospheres, but if there's no sensors that are on board the air, unless it's just visual data that the team wants to collect, where astronauts just look at the flight of the paper airplane in low density environments, we can't really quantify the data that we're looking at or quantify the flight path or the changes in flight path that we're looking at if the paper airplane is flying for a continuous period of time. The next is the sound project lacks definition. Martian atmosphere is 1% the density of Earth's and is primarily carbon dioxide, which is heavily attenuating in sound. There's no frequency range that is specified. The sound source or detection apparatus is described, but there's no mention of calibration. I would just like to understand that and how it would operate functionally and effectively in low pressure conditions. Next, the rover design lacks critical specifications. The frame material aluminum 760 is undefined in engineering standards. The wheel count is unclear. It said 6 or 8, and both are mentioned. There's no steering configuration or suspension type, for example, active suspension or anything like that. Um, and there's no mention of calibration for that too. Okay. Next is the radiation exposure is described generically. There are no target dosage values, no shielding assumptions, no radiation type differentiation, for example, like GCR or SPE. And the Martian crop section generalizes gut microbiome changes without detailing dietary tracking, controlled conditions, or microbial sampling methods. There's no soil stimulants that are specified, um, no control over variables such as hypobaric stress, nutrient content, or plant pathogen interactions. Next is the regolith canvas proposes artistic shaping of dust, but does not describe compaction measurement, cohesion forces, or erosion modeling. There's no empirical dust behavior data, and there's no testing for um, the triboelectric effect, for example. And the dust devil dance references vortex generation, but it doesn't define pressure conditions that are being analyzed and looked at. For example, like if we want to get accurate data for how dust behaves in the atmosphere and how it can pose challenges to the astronauts that are on the surface of Mars, we should probably experiment and collect data and create a simulation where the dust is being, where the vortex of dust is operating in the types of pressure that we would normally see in close to the Martian surface. Next is the shallow ice extraction experiment assumes accessible low bait debris aprons without stimulating Martian subsurface conditions. For example, the drill torque, penetration depth, energy budget, and mechanical performance are unspecified. Next is the hydrated mineral water extraction. Doesn't specify the temperatures needed to release water, which typically require like greater than 300 degrees Celsius. And like really, there's no method of water capture for the Marsonautes to use. I understand that the drilling and water pump is specified, but I was just wondering how the water would be captured and stored, especially near to the Marsonautes, to mitigate the travel time. Lastly, the dust to glass sintering lacks data on sintering temperatures, energy input methods, or resulting material properties. There is no assessment of mechanical strength, porosity, or brittleness in the sintered products. And yeah, those are my critiques for um, the Solace team. If anybody else on Soraya Academy 1 wants to give critiques, uh, the stage is yours.
Is anyone else on your team doing critiques or are you done, Rahul?
Um, I think I'm done. I don't know if anybody else has critiques. Um, Nobody else has critiques. Yeah, we're
Okay,
done.
awesome. So we'll start the Soraya team 2 at the scheduled time. The team ADS, are you here and do you want to do a quick critique before the next team starts, since we have a few extra minutes? Team excuse me, AD Mars Pioneers, I'm sorry. AD Mars Pioneers, is there anyone here? Okay, we will start in 13 minutes with Team Soraya 2.
Manahal?
Yes,
No, I'm asking Manahal if she can unmute and if she has any questions, she can ask right now, right?
sure. Is he going to ask questions or give a critique?
I mean the critics, yeah.
Okay, yeah, he has 12 minutes. Go for it. I have a great question in the chat. The recording will be provided on YouTube as were all the other recordings, including Monday's recording. It is all available on YouTube. I believe I sent the link. They may not have a good connection, so just stand by for the next team. Go ahead.
I am Minahil Mentor of AD Mars Pioneers team. I like to ask questions to Team Phonics. Some questions like I really like the visual presentation. Can you explain how the satellite or laser signals work in deep space conditions? Next question is that the slide mentioned radioing communication. Could we expand on how that's maintained between Mars and Earth over such a long distance? Next question is that good job. Can we also discuss how artificial intelligence might help in communication or data processing on Mars? In Did you calculate how much energy each system will consume daily and how did you balance the supply demand? And my question is that only to Team Phonics that. Can you listen me?
Are you done asking questions?
Yeah, I am done asking questions. I am just asking some question to Team Phonics and
Okay,
that's done.
so this is not a question and answer session. They will answer the questions in the next session on Friday. This is a critique session. So do you have any questions or critiques of any other teams?
No.
Okay, thank you very much. We will start with the next team in 6 minutes.
I'm from Sarai Smart School Team 2, and I will give my points about this file of Solacity. Firstly, I will go or I will import my all of my points in 3 phases, and every phase have some points. The phase 1 is about the location. In their file of the location, they said a lot of important things about the location of Diotrinolius or Diotrionelius Mansei, and all of its specifications like the maximum depth of ice, the numeral location, and a lot of things about the location. But the problems are we have a lot of little informations about this location. The sources of these informations are not have a very big resolution. And the previous vehicles that were above this location had some problems like the connection. The second phase is about the kilo power. In the kilo power, we have said that the kilo power can get or can make a lot of things like get the most important or very most important power to charge a lot of vehicles and a lot of my technical things that I put it on Mars. So the problem is what is the what are my points or what are the homework of this kilo power where I can put it correctly to do its its homework correctly. Okay, and the phase 3 is about the agriculture or the agriculture in Mars. They use as I show the regolith in cultivation of CO2 and O2. But there are some problems about we have two technical things or we have two technical types of agriculture that I can use it in Mars or in the lunar missions, MOXIE and ROXY. Correctly, the technical type that they can use it in Mars is the MOXIE. And the ROXY is better of that because the ROXY I can use ROXY correctly on Mars because previously when I use it on the lunar missions, the agriculture under the lunar cannot have a lot of amounts of CO2. So We can use it on Mars because it have a lot of resolution and a lot of efficiency in Mars. And we can talk about what is his numeral data that he dependent about it. This is very important because in the vehicle that use it example, he don't show a lot of data that it were very important. So I thought that this is the most important three phase that we can talk about it. And there are addition things about the data that the file hadn't make its or hadn't dependent on its carefully or independent sequentially. There are have the file hasn't have the sequentially in methods. The methods were very have randomly sort. This is all of my points, Mrs. Thanks you.
Thank you so much. And the next team that presents will be Team Solace, Society of Life, Astronomy, and Cosmic Exploration. So stand by. I will stop the recording and they will start in 20 minutes. Yes, Mohammed?
Excuse me, ma'am. Can I, I'm from Surah Smart School too. Can I give my critique?
Absolutely. I thought
Thank you.
you guys were done. Please accept my apologies.
Thank you so much. I would just critique Team Solus. Firstly, you guys have done a great work, but I will have some points. The Kalani's installation system composed of HDPE and waterproof layer lacks detailed engineering specifications for how the panels will structurally secured, like the panels of water and the panels of HDPE. How did you structurally compose them with the habit main construction? Secondly, we have the agriculture environment's design remains unclear, and the soil treatment protocols are prone to failure, with no compensation program in place to address potential crop losses. Meanwhile, the use of the aerogel to insulate water reservoirs, or the water tanks, is insufficient for achieving the required internal temperatures, as it only provides thermal insulation rather than active heating. You have to provide some system to heat up the water. Aerogel just provide the insulation, doesn't give any heating. Furthermore, the specific properties of the Martian soil needed for agriculture have not been defined, or nor the optimal collection sites for the depth from which soil samples will be extracted from the Martian surface. These unresolved issues highlight critical gaps in the planning. I think they will give even risk mitigation. This is all. Thank you.
Anyone else from Soraya 2? Would you like to critique? Okay, if no one else will critique, we will start in 17 minutes with the next team. Yes.
Thank you. Trisha, please begin.
Judges, scientists, mentors, fellow explorers. As we look to Mars, the ambition is clear, but the path demands rigorous examination. While the dream of a new home beckons, reality demands an unsparing look at the proposed blueprints for our future. Embarking on a human mission to Mars represents the pinnacle of space exploration, demanding meticulous planning, cutting edge technology, and unwavering realism. This presentation provides a concise critical assessment of various proposed mission architectures and plans. Our analysis highlights fundamental flaws, overlooked critical details, and unrealistic assumptions that could severely jeopardize mission success and crew safety. Ria, you now have the floor.
Next, we'll walk through our detailed critiques for each team, pointing out key gaps, feasibility issues, and suggestions to strengthen their design. Disclaimer: we have not received presentation for Saria Academy 1 and Red Horizon and have hence not been able to critique them. The oral presentation is just a summary of critiques with them written in detail on the slide. This has been done due to the limited allotted time. Most teams missed a detailed mass breakdown, which is crucial for mission feasibility. Also, none included emergency plans like radiation shelter or astronaut death protocol, big safety gaps. Next, we'll dive into our detailed critiques, starting with Team Phoenix. So first, the single undifferentiated habitat model with no private areas will inevitably lead to chaotic living conditions and really hurt crew mental health because there's just no personal space. Then there's a greenhouse relying on complicated, unproven, treated Martian soil leaves no fallback if it fails, and it completely neglects simpler, more efficient hydroponics, which would have been smarter for a first mission. The crew size is another big issue. Having just 4 astronauts fundamentally ignores NASA's redundancy requirements in case of illness or death, makes rover trips impractical, and skips over established mental health protocols for small and stressed crews on long missions. And finally, the power plan. Prioritizing solar as primary power with 4 kPa reactors only as a backup wastes mass and show poor planning, especially since fans can't really clean solar panels in Mars's thin atmosphere and manual cleaning just eats the critical crew time. Next, the rover's only stated purpose is a scout terrain, which is really an inefficient use of critical mass because high-resolution orbital data already does that better. Plus, they haven't included rover speed or identified pre-scouted sites, which shows big gap in operational planning. Then, there's a persuasive single-point failures. They've completely ignored redundancy in sync life support, power systems, and inflatable habitat. This means a single thermal event, micrometeorite strike, or pressure loss could be a catastrophe. And internal polls they mentioned, they won't actually prevent the collapse. Psychological health is another huge miss. For 18 months of isolation, they have offered no dedicated support mechanisms, and the medical bay is simply reduced to a single bed without instruments or testing. So, mental health crises and emergencies could be disastrous. They've also misplaced priorities, focusing on industrial scale experiments like concrete and metal extraction, which are really impractical for a first mission. Plus, unrealistic design choices like transparent windows for recharging in low light and dust, and an unnecessary fuel purposing plan that just wastes mass. And finally, there's a direct regulatory issue. They've completely ignored planetary protection protocols. Without a COSPAR compliant quarantine for sample return, it poses a major contamination risk to Earth, a clear violation of international space law. Trisha, the mic is now yours.
Trisha, are you there? Okay. For Team Saraya's Saraya 2 critiques, first, okay, please continue.
For Team Saraya 2's critiques, first, regarding your 4 critical rovers, what are your contingency plans if one fails to activate or malfunction miles away, with no one there to fix it? Secondly, your entire premise hinges on achieving close to 100% in situ resource utilization. This is an extraordinary claim that even NASA considers decades away. What specific DRL-9 technologies are you deploying to process every required resource, from construction materials to breathing air? Or is this simply a baseless aspirational goal with no engineering to back it up? Vehicle specialization justification. Splitting NASA's integrated MMSEV into 4 specialized vehicles unjustifiably escalates complexity, mass, power, and potential points of failure for a mission with severe resource constraints. Electronic suspension feasibility. Replacing robust active suspension with an electronic one based on an RC car is fundamentally unserious, entirely lacking proof of concept for Martian loads, extreme temperatures, radiation, or abrasive dust. Moving on to your proposed habitat construction and resource management challenges, we observe several critical issues. First, regarding 3D printing shape memory alloy wheels. Your claim to 3D print complex shape memory alloy wheels on-site is either an unsupported aspiration demanding staggering resources or simply an experimental technology presented without clear integration into your plan. Next, concerning Martian habitat construction, your plan to 3D print habitat iron and clad it in polyethylene fundamentally misunderstands energy budgets and chemical processes. A 10 kilowatt kilopower reactor cannot support industrial scale metalworking, and polyethylene cannot be manufactured from the Martian atmosphere by the Sebaceous reaction without an unmentioned chemical plant. And finally, on waste and biomass recycling 100% of human waste and biomass into fertilizer is an unproven, non trivial challenge. Your proposal lacks specifics on pathogen destruction, brine management, and nutrient balancing, offering no redundancy or proof of concept for this critical salvation sensitive closed loop system. Now, to critique Team Aries X, I will hand it over to Laksh.
Okay, so let's start with the fundamental flaws in the mission planning. There has been a gross mass underestimation. This is again for Team Aries X. The proposed 30-ton mass for an 18-month mission with extensive ISRU and a 200-meter cube habitat is wildly unrealistic, making the entire mission impossible from inception due to severe mass underestimation. Unfeasible habitat excavation is our next point. The claimed 20 to 30 hours for excavating the pit with a water-specific, rover-based drill, which is the red water system, is physically unfeasible, as moving hundreds of tons of regolith would realistically take weeks. Then, moving on to critical safety and operational risks. There is an unproven bio-ISRU reliance. The mission depends on experimental genetically engineered microbes for life support as well as other very essential things. These are decades away from reliable application in sustaining human life on Mars. High risk, this is especially high risk as it is a primary and essential part of the mission. Moving on to dangerous EVA protocols. This features a fatal mismatch with only 5 minutes of emergency oxygen. This is not feasible for an actual emergency. Flawed fire safety. Sealing a burning inflatable module is insufficient. It risks total loss without active suppression. And lastly, we go to unrealistic biocontamination controls. There are claims of safe, engineered microbe release, and this is irresponsible, violating planetary protection and risking irreversible Martian contamination. Now, I will take you through the rest of the teams. These are mentioned in much more brief in comparison to the previous ones. Let's start with the Fantastic Six. This team's proposal is critically incomplete, omitting essential elements such as rovers, spacesuits, radiation protection, and basic habitat specifics, leaving major gaps in their mission planning. Team Red Discovery's focus is misdirected, dedicating unnecessary attention to rocket ship details which are outside project guidelines. Consequently, they neglect core mission components like rovers, habitat designs, radiation protection, and critical power sources. Team Young Sheldon. Their plan is severely incomplete, lacking basic mission specifics like a pressurized rover and more habitat details. Furthermore, their power strategy is fundamentally flawed, relying on woefully insufficient RTG primary power and ineffective wind turbines. They are ineffective because of Mars's thin atmosphere. Then we move on to Team 80 Mars Pioneers. This team excessively focuses on unrequired launch and travel plans, as well as challenges of Martian space travel. while minimally addressing crucial protection and operational details. The rigid module mass is way over limits. Crops risks of mental health, meaning that there is very limited crops that will be grown, and this will take an effect on the crew's mental health. And nuclear power is incorrectly regarded as a backup. Then we have Team Star Club. Team Star Club lacks justification for mission duration and omits key protections like radiation and planetary protection. They neglect ISRU and geology experiments, propose an unoriginal drone which has already been sent to Mars, and risks mental health with no private crew quarters. Then we move on to Project Ares. The current plan for a four-member crew is unworkable and will negatively impact both mission success and astronaut well-being. Further, their proposed hovercraft is impractical for Mars's low-density atmosphere, making a rover a more suitable alternative, but that has not been mentioned anywhere in the presentation. The inclusion of four drones is also questionable, offering limited scientific potential given prior testing with Ingenuity, and their power source remains unaddressed. Other drones. Finally, the reliance on a plasma magnet for radiation protection is based on extremely futuristic technology, at least 20 to 30 years away from now. This is not yet viable for a near-term Mars mission and introduces unnecessary design complexities. Then we move on to Team Ascent. A four-person crew for a Martian mission is highly risky, impacting mental health, mission efficiency, and lacking skill redundancy. While the habitat is planned for a lava tube, the proposal fails to address crew housing during scouting and construction, and establishing a base within unstudied Martian lava tubes poses significant risks like unstable structures or high temperatures. There have also been no contingency plans for what will happen in a collapse of the lava tunnel. Additionally, radiation protection layers inside a lava tube are unnecessary and a waste of mass. Lastly, the proposed drones, all of which are identical and overly complex, will yield little scientific data, and that mass could be better allocated into studying the insides of the lava tubes, which, as a scientific goal, has also been neglected in the current mission plan. Team Genesis. The proposed design fundamentally misunderstands basic human mission requirements, rendering it unfeasible and dangerous. It catastrophically underestimates mass and radiation shielding, while lacking crucial provisions for medical emergencies, spare parts, thermal control, dust mitigation, and life support redundancy. Furthermore, it makes blatant factual errors regarding Mars's environment, magnetic field, and atmosphere, and even non-existent NASA vehicles as reference, completely undermining its credibility. In reviewing all the teams, we saw remarkable creativity and genuine enthusiasm to design missions that could take humanity to Mars. But mission design isn't only about big ideas, it's about making sure those ideas can actually work under Martian conditions. A sustainable Mars mission needs more than inspiration. It needs robust redundancy, precise mass and power planning, credible science goals to go beyond what past missions have done, and above all, designs that put astronauts' safety first. All of which are core fundamental concepts behind our own design report. In the end, turning vision into reality depends on merging innovations with engineering discipline. That's what will truly move us from a dream to Mars to actual footsteps on its surface. So, thank you for this opportunity, and let's see you on Mars.
Thank you, Team Solace. That was a great critique session. I hope the other teams take those critiques into account. And we will start with the next team, Genesis, in 5 minutes. Is anyone from Team Genesis here?
Yes, ma'am.
Okay, we'll start in 5 minutes.
Amir, could you please put your video on? All right. So I'll be starting on a self count of 3, 2, 1. All the teams did extremely well, and we truly see a true enthusiasm to go to Mars. However, some ideas just have to be slightly refined and critiqued, and some ideas could prove utterly disastrous to a mission. We'll start with the critiques for Team Solace. So, in your presentation, you talked about the crew mental health, and that's amazing, of course. But we feel it could be connected to how the habitat would be designed. Like, you didn't talk about features for crew mental health in the habitat. And psychological support systems are still just ideas they currently do not exist. There were no physical features like private pods, adjustable lighting, or soundproof areas mentioned in your presentation. Also, ISRU systems weren't included, no MOXIEs, no tools for digging up the records, and no mention of systems to recover water on Mars. The habitat is one big structure. There are no separate sections to handle emergencies like fires, pressure leaks, or radiation. And for the food plan, it completely depends on Earth. So there are no greenhouses or recycling methods in your mission, which makes the crew extremely vulnerable if supplies are disrupted somehow. The science mission isn't very clear, we feel, because no tools like soil samplers, spectrometers, or geosurvey equipment is mentioned. And also, what about dust issues like airlock systems to trap dust, or sealing or filter maintenance in case something breaks in your habitat? For medical care, it's just emergency response. There are no tools for medical care like ultrasounds, telemedicine, and no isolation area in case of diseases. And about EVA activities, there are no rovers or docking stations in your mission, just long walks, which could prove disastrous in case of an emergency. The power system is very vulnerable to breakdown because it's all in one line. There are no backup batteries, RTGs, or microgrids. And there's no plan for growth at the end. So presenters didn't talk about future phases or modular base exploration for future missions to Mars. Next, we'd like to critique Team Ares X. So the judges question your crew skills and fuel logistics already, and we don't personally think your answers are strong. If you could go into greater detail in the answer session on 18th. In your mission, there's no radiation protection or backup life support systems because everything is single use, which A creates litter and makes you vulnerable to emergencies. So there's also no fuel made from local resources, no methane production, and no plans for rovers or return trips. The crew has no biology knowledge in their roles. The science lead is missing, and only engineers and pilots are mentioned in the roles. As we mentioned for Team Solace again, all of your food comes from Earth, which is massively vulnerable in case anything goes wrong via Earth to Mars. And science plan is way too general, no specific mission objectives, just geology and biology, which again you can't do without a specialist biologist. And no robots, all maintenance is done manually during EVAs. And about your communication systems, it depends on one uplink. There are no backup satellites or local repeaters. And one thing that is critically lacking from your presentation, for 1.5 years, four astronauts alone on Mars. Do you, Team Ares X, do you honestly not think mental health shouldn't be mentioned because it wasn't mentioned at all in the presentation? And there are no plans for protecting against storms or even about the radiation levels on Mars. There are no plans for future expansion because the mission is seen as a one-time event with no follow-up structure on Mars. Amir, the floor is yours now. Amir?
Yeah,
All
hello.
right. Yes, the floor is yours.
Okay, so the next team is Team Young Sheldon. Um, I think the habitat is small and too dense with no protection and no buried or shielded structure. The medical and mental health roles are too general with no specialists. No use of local resources, life support, all the life support was from Earth. Food is only packaged, no plan for growing or reusing food. No scientific tools like drill sensors or analysis equipment. No mobility tools, only working for EVA. And no emergency backups, no suit protection or secondary habitat. The risk of dust is not addressed. There are no filters or cleaning methods, and no plan for crew stress or loneliness, and only team bonding activities, and also no system backups like life support or communication lines. Um, and then we have Sarai Academy 1. The shielding wasn't planned. The habitat was alone without a regular shell or any kind of shell. No use of local resources or environmental systems. The crew was unclear with no engineers or science leaders. It was too general. Food plan wasn't really sustainable with no greenhouses or variety beyond canned food. Science ideas had no tools or tests, and no rovers or transport. Movement was only on foot, and I don't think it's really that good. Medical support was pretty weak, only first aid and basic health plans. Um, the power system was single layer, solar only without backup or batteries, and no recycling or waste management because it wasn't mentioned anywhere.
Next, we have Team Saraya Academy 2, second team from Saraya Academy. So, starting off, your habitat was too small and sealed. So, in case of damage to a part of the habitat, the entire habitat would likely be breached. And of course, it's also not good for long stays. You haven't, in your mission plan, you haven't used any local resources or recycling. And your presenter said no water or oxygen reuse, which we feel is completely unwarranted because we will need oxygen or water reusing on Mars to save resources. Again, as we said for the previous team, there are no specialist roles, no science, medical, or technology leads for complex systems. Now, one of the most important critiques for this team, there are no backups for your environment or for power. So, in case of an emergency, your entire system could fail and you would be doomed. Next, we move to Team Phoenix. Your habitat is very without regolith cover on the Martian regolith, and the entryway to your habitat was very vulnerable to storms, Martian sandstorms, and dust storms. There are no ISRO extraction systems on your mission, and speakers validated life support dependent on delivered provisions. So, Team Phoenix, what happens if these provisions aren't delivered and you're stuck in Mars without provisions? There are no backups then. Your medical team was insufficiently developed. They're missing diagnostic tools or telehealth options. The diet plan was fixed, and we think astronauts on Mars will be getting tired of eating the same food every day. So, no protein cycle integration or hydroponics. And this is one of the major critiques for this team. Your exploration was confined to EVA. There is no rovers assigned for crew logistics. How are you going to explore a greater area on Mars? For your medical toolkit, we feel it's way too limited. There's no reference to imaging or surgical capability. Psychology protocols in case of mental health are completely absent, and morale problems are just overlooked. The power system was missing a storage description. There's no battery banks, there's no energy balancing strategy, etc. The science section we feel was very general and vacant. It lacked equipment, collection, or analytical techniques. And lastly, for this is a general critique for most teams, honestly, there's no scale up strategy. The mission is characterized as time limited exclusively, and so you have no plans for future missions or infrastructure to leave behind on Mars. Next, we move on to Team Squad Red Horizons. So, first of all, your radiation shielding diagram is way too superficial. It lacks completely mentioned construction methods or layer thickness. And we feel your life support was too brief and because O2 and humidity cycles were completely overlooked. Your EVA and medical positions are completely merged, so no secondary teams or any outlined emergency procedures. For food planning, we noticed you didn't include a contingency rate, so caloric or backup measures would just not be there in case of an emergency. In the exploration strategy, there is no rover or transportation system included, which leaves you to only explore a very short distance around Mars. Scientific objectives. We feel we're missing one major scientific objective, a reference to life detection. Teams Red Squad. This is in your science division. It has no life detection, meaning even if there is life on Mars or was ever life on Mars, won't be able to detect it. Secondly, in your habitat, the radiation protection is lacking and there's no refuge from solar storms. And finally, there's no psychological and exercise facilities in your mission. There's only basic fitness regimen. And lastly, there is no dust management in your mission. I believe even the judges highlighted this. Finally, we have Team Scarlet Exploration. In your systems, there's no redundancy. Air, filtration, and heating operate at a single point. In case that point is destroyed in an emergency, all three of those, air, filtration, and heating, would be destroyed. Oxygen and water are completely sourced from Earth, so in case of breakdown of resources, you will not have any more. Crew positions are completely general, not focused on science, medical, or systems. There are no surface vehicle or rover designs presented. The food resilience is weak. There's no strategy for storage loss, contingency rate, or failure. Research that lacks hardware or methods is simply referred to as science in your presentation. In your medical instruments, they are completely passive. They have no diagnostic or monitoring capabilities. Your crew well-being strategy, psychological and mental health, is completely absent. There are no social support systems or psychological trauma resilience. There is no dust control in your habitat and rovers, no seals, filters, or sanitation. Yeah, that's it. Thank you. Thank you. That's it.
Is there anything else from your team?
No, miss.
Okay, is anyone, okay, so Team Phoenix, you will start in 8 minutes.
Ani, you can go ahead and begin if you'd like.
Okay, so we're gonna start with Team Solace. First critique would be the weight of your crystal cage. Just looking at the picture, that cage that you've created is huge. And seeing that you have said that you were going to make it out of plastic sheets, that becomes really heavy. I want to know whether or not that actually stays within the weight limit of the actual that's been given to you. And my second critique for Solace would be the walls that they showed. How do you actually plan on terraforming? Because it's not just Solace, there's other teams that did this as well, but how do you plan on terraforming those walls, seeing that you have no actual equipment that you've specifically added in order to terraform? Asa, if you want to keep going.
All right, yeah, thank you. The next thing is that you claimed your reactor was based on the kilopower unit, but then you also specified that it uses a turbine that is powered by steam to create rotational energy. This is not how kilopower works. It uses 8 Stirling engines that convert heat to mechanical work that is converted into electricity. The next thing is that your habitat in the picture is extremely large. So I was wondering is the weight of this thing really in the parameters of the competition? The next thing is that you mentioned using a lot of AI integrations in your mission. Do you have the power and processing power for all of these integrations? Was wondering that. And the next thing is that your presentation mentioned having 6,000 kilograms of food since you had 6 astronauts, I believe. But a spreadsheet on the subsequent slide only said 3,000. So just making sure there's no discrepancies between that.
we had a quick question about why not all 6 candidates are merit-based. Instead, they're split up into 2 have to be male, 2 have to be female, stuff like that. And this is kind of a general thing for most of the teams that rely on hydroponics, but as a food source, it's fine, but it doesn't really prove that we can grow food on Mars. We know that we can grow food hydroponically. We want to, as a scientific goal, we want to prove that it can be grown on Mars as in Martian soil. So discovering ways to fixate that would be, pretty important. I think, Ani, you have one for Team Genesis.
Yes, for Team Genesis, I do, if I remember correctly, you do send your reactors up separately beforehand before the actual astronauts come. So how do you actually plan on setting these up? Right? If something happens to these reactors, do you have any like contingency plan for that? I didn't really see that, and that was my main critique for Genesis.
I'll come back here. I just have a few general critiques for a few other teams. One for Red Discovery. I think you mentioned having your oxygen tanks at a pressure of 518 atmospheres. Now, you can rebut me on this, but I think that would either explode or your oxygen would be in a supercritical state or solid. So you may want to double check that pressure number. Project Ares, in your diagram, your habitat airlock had no external door. So this would mean you'd either have to depressurize the entire hab every time someone entered or exited, or it would depressurize violently and kill everyone inside. I think you mentioned you building a hab pretty much entirely out of carbon fiber and aerogel. Just wanted to say that's extremely expensive. While it does work well, that you got to think of cost concerns. Similar to a habitat, the greenhouse unit has no airlock in the diagram or specified, meaning that if you open it up to the Martian environment, all the water in the plants would boil and kill them instantly due to the rapid pressure drop. A few other missions do this, but if the food production is a failure in this mission, your astronauts will starve. You don't have enough food in case the food production does not work. You also had a variety of foods, but you didn't specify any like cooking equipment or anything, so the astronauts just expected to eat these plants raw? Or is there a way to kind of enhance them at all? Because eating raw potatoes, tomatoes, stuff like that would actually probably lower your morale in the long term. Next thing, Team Young Sheldons. You specified bringing an entire excavator. I just think that weight may be better placed somewhere else. I think someone else mentioned this, but you only specified having one RTG unit, which do not produce a lot of power. I don't think it would meet your demands. You also specified having wind turbines, and Mars's winds are not very quick, meaning you'd either have to make them very light, and therefore they would not generate as much power, and they'd also have to be very small, which means less power. Your rover is unpressurized, which means that the exploration time in it is limited to the crew's oxygen supply in an EVA suit. And you specified using a heavier zero gravity suit instead of a specialized Martian suit. And the next thing is, and the last one is for Soraya Team 2. I was wondering exactly how the telescoping system changes your vehicle's dimensions. That wasn't really specified in the diagrams. I was wondering, why would you print your habitat on site instead of just printing beforehand, considering it's made out of, I think you said polyethylene in metal, and a rover would not be able to gather polyethylene and be able to print metal just scooping up materials on the surface of Mars. Metal 3D printers are ginormous, and you need a chemical plant to produce polyethylene, as ethylene and other alkanes don't exist on Mars because they're organic molecules. You had quite a lot of rovers. Do you think this weight could be distributed somewhere else rather than having so many of these? Like I mentioned before, ethylene production on Mars is hard considering you have to synthesize it, like another team earlier, you depend on growing food, and after 2 months, or the astronauts will starve. And once again, I mentioned this, but growing food hydroponically doesn't really prove anything except that it does produce food, obviously, but it's not really a scientific goal. And I think that's everything we have. Thank you for listening.
Thank you so much for your critiques. Very nicely done. Is anyone from Project Ascend here?
So I really don't have any critiques other than this one. So on some people's videos I was looking over, there wasn't any communication systems on some of them, which I feel like is a crucial role because how are you going to communicate with your astronaut? That was just the one critique I had. Thank you.
Thank you, Elena. Is anyone here from Project Aries, Young Sheldon, Star Club, Aries X, or Red Horizon?
So I'm gonna start with Team Phoenix. So the time will be taken, you said that the time will be taken up to set up such habitat, and so what is the time to set it up? You didn't really mention, and where will the crew be during this time? And if they will be in the spacecraft, will they have enough radiation protection? Because this is also not really mentioned in their video. And it's a key part because crewmates' health is the main issue, and including the fact that many spacecrafts have with shielding are penetrated by GCRs. So, a question to Team Genesis and Phoenix would be, as your habitat will be set up, how do you plan to move your equipment from the spacecraft to the new habitat? Because we have limited resources, we have limited weight, and we can't really bring that many rovers and stuff. And as to Project Ares, you chose a landing site as the Jezero crater, and how sure you are that the water in the form of ice is actually present there, because as per ice per consistency maps, the data set is not consistent with the ice being there. And is there any proofs that indicate that there's presence of ice? And it is very important to send the crew to the place which is mostly believed to contain crucial resources for the mission, such as water. So what makes you think that the Jezero crater is actually suitable for life? Because not just because NASA sent rovers there, it doesn't mean people can live there. And as for Team Ascent, for the landing position, you said that water is in 0.7 meters depth, and I want to know that where this information was obtained, as per new ice consistency map. The point which you indicated as the landing site is believed to have an ice consistency value of 0. This means that there's data set is not consistent with ice being there. So are you sure that water is there? So if so, what are the proofs? Because again, water is the most essential resource that we will need on Mars. And if these resources aren't acquired or cannot be acquired properly, then what's the point to go there? The astronauts are gonna starve or even die. So these are my questions. Thank you.
Is there anything else from your team?
As far as I know, probably not. I'm the only one.
Okay, is anyone here from the Young Sheldons? I have put an email out for everyone who has not shown up yet and asked if they will be showing up. And if I do not hear from them in the next 15 minutes, we will end this presentation.